string, papers, and stool.
So I thought I'd just make this short video to show you the geometry behind the geobender. It's quite fascinating because the side of the cube obviously is unit. Let's say it's 1. So I'm drawing two sides here and then the diagonal between them. And if you have Pythagoras theorem, a squared equals b squared plus c squared, the longest side is a squared. So the longest side would be 1 squared plus 1 squared would be 2, and the side would be the root of 2. So 1, 1, and the square root of 2. Now, the next thing we're going to do is, what would the diagonal be? And if you work it out again by Pythagoras, you find that it's root 3 is all the way down, and halfway, or rather to the centre, is root 3 over 2. So now I've taken a compass and I measured out exactly what root 3 over 2 would be from each of the points on that triangle. And then we're joining up the points with a ruler, one going this way. So that's root 3 over 2. This one's root 3 over 2, all those the same distance. And the next one will be root 3 over 2 because we've measured them all with the compass, they're all going to be the same distance. And the next one we join up, root 3 over 2, and the final one, oh, there's one more I think down there, root 3 over 2. So all these are root 3 over 2, the main triangle is 1, 1, root 2, and all these bits around it root 3 over 2. And then we have to put little flaps onto it so that we can glue it together. So we just add on a little flap at each corner and over one side. Yes, that will stick onto the next bit. And here's me writing down the numbers. 1, root 2, root 3. That's the different proportions. But now the sides need these little bits, just roughly that size. You may have to adjust them a little bit when you're putting it together, but when you've got that shape, you're ready now to cut it out and then fold it together. And that's what you see in the next video. Okay.